All right, so let's take a look at number 13, and there's a problem with number 13. So if x is greater than or equal to 0 and less than or equal to 3, then 15 minus 8x plus x squared is less than or equal to 0. This statement is false. And the reason why it's false is that if x equals 3, then 15 minus 8 times 3 plus x times 3 squared, okay, is going to equal 0, which is in fact equal to 0. Oh, excuse me, this is strictly less than 0. Sorry. Strictly less than 0. And so consequently, false. Okay? But if we change, so hence why I've got to get rid of 13. Okay? But if we change the statement to if x is greater than or equal to 0 and less than 3, strictly less than 3, then we get 15 minus 8x plus x squared is going to be less than 0. That, in fact, is going to be true. And let me go through, and I'm just going to prove this one, just for the sake of learning, and because proof is proof. All right? So let's let p equal the statement x is greater than or equal to 0, and x is less than 3. So not p will be equal to x is less than 0, or x is greater than or equal to 3. Q will then be equal to 15 minus 8x plus x squared is greater than or equal to 0. Okay? And so not Q is going to then equal 15 minus 8x plus x squared is strictly less than 0. So if what we get is we get not Q implies not P, which is our contraposition. So if 15 minus 8x plus x squared, okay, is, excuse me, that should be less than or equal to 0. This was, in fact, less than 0. This is now greater than or equal to 0. Excuse me. So if we take not Q, then we get 15 minus 8x plus x squared is greater than or equal to 0. Then x is less than 0, or x is greater than or equal to 3. Now the fact of the matter is that I only need one or the other of these. That's what the or means, right? So if x is less than 0, or if x is greater than or equal to 3, then what I end up with is I end up with a straight true statement. So we're going to let 15 minus 8x plus x squared, plus x squared is going to be equal, we'll set it equal to 0, implies that 5 minus x times 3 minus x is equal to 0. Okay? So, in this case, x will equal 5, or x equals 3. Okay? Using a little bit of algebra, laws of algebra apply, we can always use them. If x is greater than or equal to 3 and less than or equal to 5, then 15 minus 8x plus x squared is going to be greater than or equal to 0. Okay? And you can go ahead and check that. You can use one of these intervals. And if you use an interval, you have 3 and 5. Okay? And what you'll see is if you pick a number that's less than 3, this is going to be negative. Yeah, that's negative. This one is going to be positive, and this one's going to be negative. Great. So the only time in which we get 15 minus 8x plus x squared greater than or equal to 0 is if x is greater than or equal to 3 and x is less than or equal to 5. Well, guess what? Okay? There it is. X has to be greater than or equal to 3. That's the only time it's true. So, x is greater than or equal to 3. Thus, right, okay, by inclusion, x is less than 0, or x is greater than or equal to 3. Thus, okay, that's done. We're finished. Finito. So the fact of the matter is that solving this particular inequality gives us a value of x greater than or equal to 3 or less than or equal to 5. And the truth is, that is, in fact, greater than or equal to 3. All those values are. All right? The fact that they're not less than 0 doesn't matter, because that's an or statement. All right. That's it. It's proven. I apologize for the false statement with the equality sign, but I wanted to show you that this was absolutely provable if we hadn't had that piece. All right.